Hey guys, Tyler here. So I wanted to talk a little bit about a collision detection algorithm that I use a lot and I think is really awesome. Essentially, a great man on a forum once said, hey, a rule of thumb is if you take the 3 points of a triangle, you can find the area inside that triangle. So say this one's like 200. And then we take the intersecting point, be it actually inside or outside, doesn't matter. That's what we're looking for. And then we use the top point, the actual intersecting point, and this point to create a segment. Then we use this point down here, that point, and then the top point again to make a segment here. And then we use this bottom point, this point again, and then the intersecting point to get the third triangle. And all three of these triangles will need to find the areas and then add them all together, and they should equal 200. So say this one's like 25, this one's 75, and this bottom one's 100. So those all equal 200. And why this is useful is if a point is out here, these triangles you make will be way bigger once they're added up, because you'll have this outside triangle, this bottom side triangle, and this top side triangle, and those will add up to be bigger. So we know for a fact it's outside the area. So essentially we'll just have an if check that finds the main triangle's area, then the three segments areas, and then add them all together and compare them. And the cool thing about it too is if we have a triangle here and then a point right at the edge that's technically colliding, but it's right at the edge, we'll get two segments inside the triangle that add up to be perfectly the size of the triangle, but this edge will be 0, and the edge that it's colliding upon will always be the smallest number, unless it's like a pixel right between the points, which I don't deal with in my detection, but I'm sure there's an algorithm. Hey guys, sorry, lost audio there for a second. So now that we know we can find out if a point is inside a triangle based on those three segments, all we need to know now is how to find the areas. So if we call this point A, this point B, and this point C, this would probably be A2 at that point. We'll focus on the points outside that later. But we would plug those variables into this algorithm, which is ax times by minus cy plus bx times cy minus ay plus cx times ay minus by, all divided by 2. That'll give us the area. So ax is just the x position of a, ay over here is just the y position of a, and so on. So it's really simple. It's just a matter of rotating which points you have in the actual algorithm. So to find the original triangle, it's really easy because it's just A, B, and C. But for the, let's say, this top triangle, we would want A2, A, and B. So A2 will replace all the C, and then for B, A2, and C, we'll just use A2 instead of A, but use B and C normally, and so on. And that'll return us all the areas of the triangles that we're needing to add up. And you'll just store those in a temporary variable to add up and compare as a whole. Alright, so now's the part where we look at some pseudocode. Well, this would mostly be functioning if I really did, but anyway, essentially I just set up a structure, which is triangle, another one inside, which is point, which just has x and y, and then I set up 3 points, so it has a, b, and c. then it's like try 1, point A dot x is 0, and that's just setting the variables. I then make integers of the same usefulness, it's just to make things easier to read. I just assign triangle 1, point A, x position to AX. Then I do the same for B, C, the second triangle, which is just try 2, to AX2. So the algorithm to find the area just looks like this when it's in code rather than on that website. So it's just AX times BY minus CY, and so on. And then for the segment 1, all you'll do is replace all the C variable. So instead of CY, we have AY2, AY2, and AX2 instead of CX, and so on. That'll give you all the segments. Then you'll just go like if try 1 area, just what I called it, it doesn't need to do that, equals this one plus this one plus this one, boom, that equals a hit, essentially. I couldn't remember how to spell equals right there, in case you don't know anyway. So yeah, it's a really simple process, and that lets you know if they're hitting. If you want to find out which side, you'll just check if segment 1 area is smaller than segment 2 area, and so on. There is sometimes they return the same area, so it's hard to do a check for that, but if you spent enough time on it, I'm sure you could figure it out. Anyway, thanks for watching, guys. This has been Tyler making this tutorial on a pretty good algorithm for collision detection. I'll link this whole example code in Pastebin, as well as this website. And yeah, just let me know if you have any questions, and that'll be cool, because I love talking about programming, even though I'm not the best, but I know a couple things that I wish someone would have told me. So, yeah, bye.